On this video, you will learn the very basics of one cool tool called Maven. At the end of it, you will know what Maven is, why it has become so popular in the open source world, and the very basics of how to use it. Maven is a build automation tool, or it's more than that, it's a project management tool. Maven uses convention over configuration. If you are coming with a background like Ant, or if you have used any other build management or build automation tools which use a lot of configuration, they ask you to write a lot of XML to do the build automation, whereas Maven asks us to follow certain conventions, and if we follow them, it easily does the rest of the build for us. Basically, build could be compiling your classes, preparing a package out of these compiled classes, and then even deploying them to the servers, running your tests. All these are a part of build. So Maven automates all that for us with a very minimum convention. For the JEE space or the Java space, we need to follow this folder structure when we create our Java project. Once we follow this structure with src main Java, that's where our main source code goes, and then src test Java is where our tests will go, JUnit tests. And src main resources is where all our property files or XML configuration will go. Once you follow this convention, Maven will automatically compile our classes, it will automatically bundle those classes into jar files, it will automatically run our JUnit tests from under this folder, etc. So it copies all the compiled class files and the resources into this target directory, and then it does the rest of bundling our classes into jars and even creating war files if this project is a web application project. The folder structure for a web application project will be slightly different. Then Maven will take care of the rest of it for us. Maven uses pom.xml. If you are coming from an Ant background, you would have done written a build.xml. In Maven we have pom.xml, but we do very minimum in the pom.xml. We simply declare or create with 3 or 4 lines in the pom.xml. You can compile your project and build a jar file out of it. You simply define some coordinates, which I will be showing you in the next presentation, in the pom.xml. And then once you execute the Maven clean install command, once you install Maven and you run this command from command line, Maven will automatically compile this project, run your tests if you have JUnit tests, and it will create a jar file for you. It's that easy to create or build projects using Maven. You can declare your dependencies. So if your project depends on another project or hundreds of other projects, you can simply add those dependencies in the pom.xml, and Maven will automatically pull those dependencies even from the internet. If you are using some libraries from the open source world, let's say Apache Commons, then Maven will fetch those dependencies from the internet, put them on your local machine somewhere so that it need not fetch them again. Those are repositories, Maven repositories, of which I'll be talking later. So that's why Maven is so powerful. And when you install Maven, it's very tiny. It doesn't have a lot of code or compiled code in it. Maven uses plugin framework. So when you install Maven, it's very tiny, and when you start using the different things within Maven, then it will download those plugins on the fly and then use them to create build. For example, to run the JUnit tests, Maven uses something called Surefire plugin. That Maven will download that plugin the first time you are trying to run your tests. So, and there are many other powerful Maven plugins like WSDL to Java, etc. that I will be demonstrating in the future presentations. Repositories, as I have earlier said, Maven will compile your code and put them into, or it will package them into jar files or war files and will dump it into repositories. Even the dependencies, if your project depends on another project, those dependencies can be fetched from the repository. This repository can be a remote or a public repository like the open source one, or your organization can create a local repository. There are repository tools like Nexus which support it. You can then have your jar files in the Nexus repository. Any project that needs those jar files or war files can fetch it from the repository. Maven can automatically fetch them from the repository. Maven also maintains a local repository on your desktop. For the first time you are depending on another project, it will fetch it, puts it in your local repository, and from that point in time, unless something changes, it will fetch it from the local repository. So to summarize, Maven follows convention over configuration. You need not write a lot of XML to do your project build automation. It's very easy, simply follow convention and Maven will take care of the rest of the work for us, like compilation, creating jar files, etc. And it doesn't restrict us to this. So if you want to change this folder structure, you are welcome to do it. Maven does allow us to customize it, but very rarely we'll have to do that. And then Maven is based on a plugin framework, so it's very tiny when you install it, but whenever it requires the appropriate plugins, it will download them and use them based on the command you are going to execute. These are called goals and lifecycle, Maven lifecycle, which I'll be discussing in future presentations in detail. And the key file in Maven is form.xml. It stands for project object model. This is where you define your project coordinates as well as any dependencies that project has will be defined in this form.xml. And then repositories, which I have already said, could be a remote repository, could be open source repository, or it could be something local on your machine.